Alright students, I hope you have your graph paper with you that I gave you in class, because if you don't, taking notes is going to be kind of difficult for this section. It's entirely about graphing. This is section 8.8 from your book. If you want to find the page, look it up. Anyways, let's move on. Graph each inequality. Hopefully you remember what inequalities are, but if you don't, inequalities are like equations, except instead of an equal sign, they have a greater than, less than, greater than or equal to, or less than or equal to sign for all the ones we deal with. So there's 4 different signs that we can use. This will have an effect on what the graph looks like for each of these inequalities. So we're going to graph 4 examples today, and we might go over more in class. But please remember, if you don't understand something, please do play the video back and watch it a second time, because when you're writing and listening, sometimes it's not as beneficial as just listening. So take the notes, and if you don't get it, go back and watch again to help you get it. So let's just get started. So we start off with this lovely inequality. Y is less than or equal to, y is less than or equal to negative x plus 8. So the good news is, just like how when we were learning to solve equations, and in that section, we had a section, in that chapter, we had a section on inequalities. Solving inequalities, we found out, was basically the same way. We do the same thing. There was 1 or 2 small exceptions, but overall, the same thing. That same kind of rule applies here. When we graph these, the same rule applies. There's just 1 or 2 extra things we have to do at the end. So, all right. For right now, let us begin. We have a graph here, and what we're going to do is we are going to use the slope-intercept form method of graphing, meaning no t-charts are going to be used because honestly I find them time-consuming. So we're going to use the slope-intercept form. In this form, we need to find the y-intercept first. Thankfully, the inequality is similar to an equation in the sense that once you get the y by itself, the number on this side that we're adding or subtracting is the y-intercept. So the number that is by itself right here that we're adding or subtracting, that's our y-intercept, which means that is a point on the line we're trying to make. So we're just going to go put a point right here, okay? Hopefully you can see that. If you can't, I put a point right here on 8, okay? So next, we're going to have to use the slope. Now here, this is beneficial to write down the slope over here. So I'm just going to say slope is equal to, and they tell us that there's a negative sign. And what? Now we don't put negative x. Slope is not x. Slope is the number in front of x. I don't see a number in front of x. Well, what number is there? There is a number there. They just don't bother writing it because it's not needed. So what number is there? Hopefully you remember that it's a 1. Now, what is slope? Did you just say 1? Well, that's not right. That's not x, that's negative x. So what's slope? That's right, negative 1. Very good. I feel like we're playing Dora the Explorer. Isn't it exciting? All right, now slope is meant to be written as a ratio, meaning comparing 2 numbers, because we have to move in 2 directions, either up or down, and then side to side, right or left, okay? So we're going to write this as negative 1 over positive 1. Remember, only one of them can be negative at a time. If the whole slope is negative, only one is negative at a time. So what we could do is, because we have negative 1, which is my vertical change, I could go down 1 over 1 in the positive direction. And honestly, because slope is constant, if you don't remember this, you can do this several times. If you do it up to 3 times, it's fine. You need at least 3 points. But if you do it more, I feel like it's more accurate, personally. So I just can say, well, I can start now at this point. I can go down 1, positive 1, because I'm following the directions. Negative 1, positive 1. So I go down 1, over 1 for my next point. Down 1, over 1. Down 1, over 1. And you're thinking, whoa, you're making a lot of points. Why are you doing all that? Well, I want it to be very accurate. And really, this isn't taking up any time just to do this. If I've plotted my points correctly, these should all make a straight line, okay? So we get a ruler out. Hopefully you have one at home, or you can use a straight edge, or hopefully you held on to the one that I gave you in class. All right, so we move this up like so, and now we simply connect like so, and wowee, that is a really good line. That went up to the top just where I wanted it. Awesome. And make sure you do draw your arrows like so. Now we're going to touch on one of the major differences of inequalities versus equations. And that's this whole less than or equal to symbol. Now, I hope you do remember that what I said, when we graph an equation, we're graphing all of the possible solutions for that equation. Now, an inequality technically actually has more possibilities. And we'll take a look at this aspect more in class, okay? So right now we're kind of more looking at how do you graph. But the graph has got to represent every solution that's possible for this. Being an inequality, it kind of gives it more possibilities. It's the difference back when we were solving equations where you would get x equals 5. Well, what could x be? Only 5. But if you had x is less than 5, then x could be -4 or -3 or -2. So there's more possibilities with an inequality. You could look at it like that. So, and our graph has got to represent that. And so what we do is, since it says less than, go to your line and put your pencil on your line. And this is a really helpful method. Just pick a point, like I'm going to pick this point right here on my line, okay? And it says y is less than. Now, does y affect vertical change or horizontal change? Yeah, it affects the vertical change. And if y is less, where do you think I should make an arrow going to? Down. That's less. That heads to the negative number, so that is less. So I'm going to put an arrow like so, okay? And this, you don't have to do this arrow every time, but in the beginning it's a good idea. So we're going to end up shading in all of the graph that is below the line, okay? And even over here, we're going to shade in over here because this line keeps going, so all of this is still above it. So let us begin to shade in. Well, all right, you begin to shade in. I have magical TV powers where I can just simply, snap my fingers and the whole thing ends up shaded in. So magical powers and snap. And presto, it's all shaded in. So if you need to pause the video and shade it in, you can do that. Okay, so let's look at the second one now, and we'll see the second difference in inequalities. So let's begin. All right, let's graph this one. We can do this one a lot quicker now that we've kind of gotten into the rhythm of it. So we have -6, which means we need to put a point at -6. We go down to -6, we put a point. A slope of 4/3, so that means we need to go up 4 over 3. Okay, simple enough. I can do it again. I can go up 4 over 3. If I want, I can do it another time just because I feel like it. I can go up 4 over 3. If I have plotted my points accurately, which I believe I have, they should all line up like so. Okay, that's the key. When plotting your points, make sure they line up. And the more points you have, the more it gives you to actually, line up with, okay? So, I'll make sure this all lines up, all hunky-dory. Did I get that one right? I went up. I could go down. On to, I could have had that one too, right? Okay. Up, over, up, over, up, over. Okay, good. Making sure. Just want to double check before I go and I have to make this graph. Woohoo. There we go. Now it's all lined up. Yay! And put your arrows like so. Voila. Now, this is the other difference. What do you notice different between this inequality symbol and the one from before? Okay, if you said 1 is greater than, 1 is less than, you're correct. And that is going to have an effect on how we graph that. But that's not what I want to focus on right now. That effect is kind of obvious. The second effect, the second difference, is a little bit more subtle. And it's the fact that it doesn't have the or equal to line underneath. Now, if you remember, the or equal to line meant that you can include that number as an answer. Okay? It meant that that was actually a solution for it. Meaning that if you had x is greater than or equal to 5, you could say 5 for x. X could be 5 in that situation. But if you just said x is greater than 5, x can't be 5 in that situation. So in essence, what this means is that, unfortunately, our y value cannot be on this line that we've created using our slope and y-intercept. So what we have to do is, but we still need this line as a representation, kind of as a placeholder. So if you remember when we graphed, we used to put empty circles and filled-in circles. We're basically going to make this an empty line. We do that by taking our eraser and going every few spaces and end up putting a, what would you call it, basically making it a dashed line. So go ahead and make this a dashed line, okay? And you do want to make it an obvious dashed line so that it does kind of stand out as a dashed line. There we go. Now next, it is y is greater than. This means we need to graph in what direction. Remember, go to a point on your graph, make a little arrow that points in the greater than direction for y. That would be up. And then just shade all that in. Now again, I get to use movie magic to magically make it all filled in. Ha 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 ha. Ooh, I wonder how this is going to work in the editing process, if this actually looks as good as I think it is, or if it's going to look super cheesy, I don't know. Anyways, let's go to the next side and finish our inequalities. So here we have, it says solve each system. What this ends up meaning is that we have two inequalities we have to graph, and we have to graph their systems, okay? So I am going to graph this first one, and then I'll let you look at the second one and let you try it on your own. We'll check it in class to see if you got it right. So let us begin. So we're going to graph this where we have y is less than or equal to negative 2x minus 5. So we go to minus 5 for my y-intercept. My slope is going to be a negative 2 over 1. So I could go down 2 to the positive 1. But remember, I could also say positive 2 over negative 1, so I could also go up 2 over 1. And I could go from each point to do that, to go up 2 over 1. I could go down 2 that way 1. And I'm going to make my line. And thankfully, this does have the whole or equal to symbol there. What that means is this is just going to be a pretty straight line. So we end up having a very straight line like so, okay? And so what we do is, I'm just going to, as a kind of a reminder, I'm going to draw my arrow saying, okay, I need to shade down later. We're going to wait, or we're going to hold off on the shading down part just yet, okay? We'll see the why in a minute. Now I want to make my next line, and I don't see I'm adding anything to this, which means my y-intercept is a 0. And my slope in this case is a positive 1/2, which means I'm going to go up 1 over 2, up 1 over 2. I also could go down 1 to the left 2, down 1, to the left 2, okay? So we end up with this kind of a line. Now remember, this is a less than, not a less than or equal to, so we do have to go through and make sure we put our arrows on the end. That's always a needed. But then make sure we go through and make it dashed, and we can use our eraser just by making dashes. And it's better if you really make sure that this looks like dashes and not just a button. Don't erase the whole thing, but it does need to look dashed, okay? Now this one right here, we also have to shade under because it is less than. Now once again, before you go and start shading, think about this here. We're trying to represent a solution, and since it's a system, it has to work for both. So what area here is below both lines, is underneath both lines? Well, follow along your line until you get to this point right here where they meet, okay? And since both are going down, you're just going to shade below this line and below this line. That would be this area right here, okay? So we're going to shade in all of this area, just this area right here, okay? Alrighty, well there you go. Now here's what I want you to do. Copy down this onto your note paper and use your last graph to attempt to graph this and shade in as needed. And make sure you make your dash lines when those are needed. So good luck on solving this problem. See you in class. Bye-bye.